Alright, today we're going to talk about why we've been doing what we've been doing. So, the reason why I've been factoring is to talk about quadratics. So we're going to go over graphing quadratics again very quickly, and we're going to go over concavity. Alright, so concavity. When we talk about concavity, I'm going to try to spell it. I don't have it in front of me and I can't spell it with crap. I'm going to spell it out. Concavity. I think that's wrong, but we're just going to go with it. Concavity talks about if the graph opens upward or downward. And what causes that, when we talk about if it's in standard form is ax squared plus bx plus c. For it to be in standard form, for it to concave up, a, so my first term, has to be greater than 0. Meaning that it is a positive number. For it to concave down, a has to be less than 0. So that would cause it to when we talk about concavity. If we talk about it in vertex form, which vertex form is what we've been used to seeing. What we're used to seeing. So here it's the same concept. If our number in front that makes it skinnier or wider is greater than 0, it's going to do the same thing. It's going to concave up. And if a is less than 0, it's going to concave down. So the next thing we're going to talk about, the same concept, is min and max. So if it concaves up, correct? That doesn't really look good. I'm trying to write and draw on the front. It doesn't really work out very well. So if it concaves up, then we talk about that point, whatever the vertex is a min. And when we talk about the minimum, we always talk about the y value. So I don't really care about what the x is, I care about the y value. So if it is concave down, and let's say that is at 2, we would say this is a max, and be a maximum of 2. So it's just saying it's going to the highest point, and this is saying it's going to the lowest point. When we talk about basically the highest or lowest point, minimum or maximum point, we talk about it going to its vertex. So when we talk about the vertex of a quadratic, we talk about this point, that is our vertex. When we talk about a vertex, we talk about an ordered pair. So this is a vertex, it's also a minimum, and our minimum would be at whatever the y value is. The other thing we're going to talk about is axis of symmetry. Axis of symmetry is basically saying, where would I cut this graph in half? When we talk about cutting in a graph, we always talk about x equals, or x is always our x value of our vertex. So I'm going to put numbers to it so it makes a little more sense. So I'm going to write it in vertex form. So y equals, say, x plus 5 squared minus 3. Alright, so the plus 5 is going to shift the graph to the left 5, and then the minus 3 is going to shift it down 3. So I'm going to go left 5. And since there is no negative in front, there's just a 1. So that means it's going to be concave up. So it's concave up. Its vertex is at, so vertex, I'm just going to write a V for it, is at negative 5, 3. It's concave. I'm just going to draw like a little U. If it was concave down, I'll draw like an N. This vertex is there. It has a minimum, and the minimum's at -3, and the axis of symmetry is at x equals, well, it's whatever my vertex is, so x is equal to -5. So I'm going to do another one, except for it's going to be concave down, but it's going to be the same concept. Yeah. So this time the -2 is going to shift it to the right, up 3, so it's going to look like that. So first things first, my vertex is going to be at 2, 3. My maximum is going to be at 3. My, let's say, axis of symmetry is at x is equal to 2. So that's what we're talking about. The other part of why we've been factoring, well, the reason why we've been factoring is to find our x-intercepts. So to basically go from the next step from factoring is if I have, I'm going to start off easy, x squared plus 5x plus 6. Well, that's going to factor into 2 equations, which is x plus 2 and x plus 3. Well, all we do to find the x-intercepts is set each of those factors equal to 0. So we're saying what would cause it to be 0. In this case, x would equal -2, x would equal -3. So let's say we got it into standard form, which is, this is standard form, and I still wanted to find the vertex, min, max, that kind of stuff. Well, to find the axis of symmetry, you're going to do this formula. So x is equal to, so this is the x value, -b over 2a. That's how we find the axis of symmetry. So in this case, x would equal -5 over 2. So if I graph this function, it would go through, or my axis-symmetry, the line that we cut it in half, would go through the line, vertical line, x is equal to -5 halves. So if I wanted to find everything else, I'd have to plug it in. So I'm going to do an equation where it actually works out to be pretty numbers, so we can kind of mess around or see it better. So x squared plus 8x plus, let's say, 16. So this is going to factor into x plus 4, x plus 4. So I have one x-intercept in this case, x equal -4. If I wanted to find my axis of symmetry, I'd say x is equal to -8 divided by 2, which I plug that in, and I get x equal to -4. If I wanted to find my vertex now, all I'm going to do is I'm going to take my -4 and I'm going to plug it back in to my equation. So that's going to be 16. -4 squared plus 8 times negative 4 plus 16. Well, if I do this, negative 4 squared is 16, minus 32 plus 16. If I do that math, it gives me 0. So my vertex is going to be at negative 4, 0. Since my a is greater than 1, it's going to be a min, and my minimum is going to be at 0. Axis of symmetry is at x is equal to negative 4. Guys, I'm going to go over more examples tomorrow for probably the first 2 minutes of class. That's pretty much all I wanted to go over today. So I'll see you tomorrow. Alright, today we're just going to review basically what we did today and make sure you all understand completely. There should be actually words in this one, so it should be easier to understand. And I'll throw in a song in the middle to kind of spice things up. Alright, first things first. When we talk about foiling, first, inner, outer, last. So if I gave you 5x plus 2 quantity squared, what does this tell me to do? Guys, this squared does not get multiplied inside. It doesn't just square those two terms. That is telling me that I have 5x plus 2, 5x plus 2. And from here, I'm going to FOIL. So I'm going to multiply 5x times 5x. That gives me 25x squared. I'm then going to multiply, and I'll have 10x plus 10x. Because of 5x times 2. Make sure you understand, guys, my two middle terms are always, always, always going to have an x on them. So no matter what happens, you're always going to have an x on those middle terms. My last term is always going to be by itself. So it's going to be plus or minus some number. From here, I'm just going to combine like terms. So I have 25x squared plus 20x plus 4. On the next part, is just going over factoring. Something that has a leading coefficient besides 1. Leading coefficient is just whatever number is out front. So leading coefficient of 1 would just be x squared. So this has something bigger than a leading coefficient of 1. So from here, to factor, I'm just going to set up two sets of parentheses. And when we talk about foiling, when I multiply my first two terms, it has to give me 10x squared. So the options I have there is 10 times 1 and 5 times 2. Those are my only two options. I'd say 90% of the time it's going to be the smaller numbers, depending on what this is equal to. If it's a huge number, if that would have been 60, 40, 50, something like that, I would try 10 and 1. Because it's a small number, I'm going to pick 5x and 2x. So, the next part, my last two that I multiplied. So the f and the l is going to give me my first term and my last term. So from here, when I multiply those two terms, that has to give me 18. I'm sorry, a negative 18. So I'm going to list the factors of negative 18. 1 and 18, 2 and 9, 6 and 3. That's it. Once again, the negative 3 is a small number. I'm not going to use 1 and 18. 2 and 9 are an option, 6 and 3 are an option. So, I'm just going to pick 2. It doesn't matter which 2 I pick. I'm just going to pick 2, try it out, see if it works. But when I do it, it's got to give me negative 18. So one's going to be positive, one's going to be negative. I'm going to add the negative and positive sign at the very end. But first, I got to just figure out what I have. So to check this work, I'm going to multiply 5x times whatever is there, and then I'm going to multiply whatever is there times 2x. So I'm just going to pick 9 and 2. Before I pick 9 and 2, I'm going to say, what does that sign tell me on the end? If that sign is a positive, I'm going to be adding my two terms that I get, my two x values, my two middle terms. I'm going to be adding them together. If it's a minus sign, I'm going to be subtracting those two terms. When I subtract them, I need to get 3x. Alright, so if I picked, for example, if I had a 9 here and the 2 there, automatically before I even place it, I'm just going to think, what is 9 times 5? Does 9 times 5 give me anywhere near a number that I could subtract that would give me 3x? 9 times 5 is 45. That's not going to get me anywhere close to that middle term. So I can try to switch it and just see what happens. So I'm going to multiply by 9 and 2, but I don't want to put the 9 multiplying times by 5 because that's going to give me a too big of a number. So I'll put a 9 here and a 2 here. 5 times 2 is 10x, and that's going to give me 18x. If I just subtract those two numbers, it would give me a positive or negative 8x, depending on how I subtract it. That is not 3x, so that's not going to work out. I'm not going to switch the 8 and 2, or the 9 and 2, sorry, because 9 times 5 is 45. It's too big. So I'm going to try 6 and 3. If I put the 6 here, 6 times 5 is 30. I want to get a small number, so I'm not going to put the 6 there. I'm going to try the 6 and 3, but I'm going to put it there. 5 times 3 is 15x, and that is 12x. If I subtract those, that will give me 3x. So if I just do this, 15x minus 12x, that gives me gives me 3x. I don't need a 3x. I need a negative 3x. So I'm going to put a sign here, plus sign, minus sign. That's going to give me a negative 5x, or negative 3x. So to do it, I'm going to say, how did I get 15x? Well, I multiplied 5x times 3. Well, 5 times 3 gives me 15. 5 times negative 3 gives me negative 15. So that's going to be a negative sign, and that's going to be a positive sign. And then this is going to be negative 15x plus 12x. And then when I combine my like terms, I will get the top answer. So if you want to check your work, you can always, always, always FOIL. Alright, the next part we're going to talk about is graphing in general. We're going to talk about the quadratic. Y equals x squared. It makes a parabola, it's a quadratic, however you want to write it, it makes a U. That is the parent function. We're talking about shifting it. If I want to shift it left or right, it has to be inside the parentheses. This is the only way to shift it left or right, is by putting it inside the parentheses. So this is going to shift it, sorry, not left. That's going to shift it right. If I want to shift it left, it's got to be the opposite that we're thinking. So this is going to shift it left. When we talk about the quadratic, the vertex is always basically the highest or lowest point. So this is called a vertex. When we talk about the minimum or maximum value, it's always what my y value is. So my y value in this case would be at 0. So this would be a min at 0. This here is going to shift my vertex. Instead of being at 0, 0, it's going to shift my vertex right 2. So my new vertex is going to be 2, 0. When I shift it left, my vertex is going to be negative 2, 0. So my min or max are not changing. It's just changing my vertex. Instead of being 0, 0, it's changing it either 2, 0 or negative 2, 0. So all I'm trying to go over is making sure that you understand to shift it left or right, it's going to go inside the parentheses. Alright, if I want to shift it up or down, so y is equal to x squared. To shift it up or down, all I'm going to do is add or subtract a number. So y is equal to x squared plus 5 and minus 5. So all that's going to do is shift my quadratic up or down 5. So when we talk about shifting the graph, we're talking about shifting my minimum or maximum value. So my minimum, it's still a minimum because it's still going up. My min is going to be at 5 here. My min is going to be at negative 5 there. So it's still a minimum. My vertex x value did not change, so my vertex on the here would be at 0, 5. Here would be at 0, negative 5. And I'm just going to put a v for vertex. So that's my vertex. So anytime I have a plus or minus outside the parentheses or outside of x squared, it's going to shift it up or down. Alright, the next part. So y is equal to, we'll say 2x squared. And y is equal to negative 2x squared. So the number out front is always going to make it skinnier or wider. If it is between, so we'll call y is equal to ax squared. If a is between 0 and 1, meaning it's a fraction, but not an improper fraction, it is going to make it wider. If it's a whole number, 2, 3, 4, 5, 6, 7.5, whatever it is, it's going to make it skinnier or narrower. It's not going to shift it left or right, so it's just going to make it narrower. The negative sign out front, the negative sign here is going to reflect it across the x-axis. So all that does is reflect across the x-axis, and here, this is a minimum, and this is a maximum now. So the difference is those two things. Alright, from here, we're just going to go back over everything we went over today. So y is equal to ax squared plus bx plus c. This is called standard form. We're going to deal with standard form. To find my vertex, or my axis of symmetry. So first thing we're going to find is axis of symmetry. To find my axis of symmetry, I'm going to do negative b over 2a. When I find this, so we're going to call this, after I find it, I'm going to call it n. To find my vertex is going to be whatever n is, whatever number that is. N is 5. That's my axis of symmetry. When I write my axis of symmetry, I want to write it as x equals 5, or x equals that number. The reason why is because it is a vertical line. Vertical going this way. It is cutting whatever the function is in half like this. So it's basically saying this is where it's reflecting across itself. Alright, after I find n, to find my y value, my min or max, I have to plug n back in to the original equation. So if this is going to be a that's going to give me my y value, and that y value is going to be my max or minimum value, depending if it's concave up, concave down. The next part, my y-intercept in this case, is when x is equal to 0. So if I let x equal 0, I want y'all to think about this. If x is equal to 0, those terms, my ax squared and my bx, are going to go away. So all I am left with is c. So my y-intercept in standard form is just C. Alright, the next part is vertex form. So y is equal to a x minus n plus k. This is the form we're used to seeing when graphing. I'm not going to go over what everything does, but we're just going to go over how to find my vertex, stuff like that. So my vertex, in this case, is whatever my n is. In this case, it's going to be the negative of n. My max or minimum value is just going to be k. Now I'm going to take the sign that's with k. So if it's a minus 5, I'm going to put minus 5 there. If it's a minus 2, I'll put a minus 2 there. Vertex axis of symmetry is just going to be x equals whatever n is, the negative sign of that. And then, last but not least, my minimum, or y-intercept. My y-intercept is once again the same thing when x is equal to 0. So this one, you have to plug in. So you're going to have to do a parentheses 0 minus n quantity squared plus k. You actually have to plug this one in to figure out what my x-intercept is equal to. Same concept, I have to let x equal 0. Here I'm going to have to figure it out. Alright guys, this is all I'm going to go over today. We're going to review tomorrow, and then we're going to take the test on Friday. It is a pep rally day, so it should be a shorter test. I'll make it multiple choice. Have a great evening, and sorry there was no music.